why do we call these square roots? Well, one way we could imagine it, say you take a square that's 1 by 1. So if you want to find the area of the square, you take side by side, because recall for squares, the area of the square is side by side, or we call it s squared. It's a formula for a square. So to find the area of a square, you take the width times the length, or the width times the length, and 1 times 1 is 1. Now let's say this was a bigger square, 2 by 2. Well, the area of this 2 times 2 would be 4. And then likewise, if you had a much bigger square, well, the area of this would be 3 times 3 is 9. So when we ask for the square root of 9, we're asking, well, what are the lengths of the sides of the square? I mean, and all these are all going to be the same because squares, by definition, have the same length on all their sides. The four-sided shape where all the sides are the same. So when they ask about the square root, they're saying, okay, square root of 9, what's the length of that square? And again, the area of a square is length times width, length times width, length times width gives you that. So what ends up happening here is we say, what's the square root of 9? Well, it's the length of one of the sides. Square root of 4, length of one of the sides. Square root of 1, length of one of the sides. So here's an interesting question. You notice that the area of these squares went 1, 4, and 9. Well, what if I had a square where the area was 3? What would be the length of that? And the length of this would also be the length of all these other ones. Well, it turns out, and let me get my calculator, there is an answer for that, but it's a bit tricky. It turns out to be 1.73205 0807 5689, and then it keeps going. My calculator just ran out of space. What's going on here is these digits will appear forever. They keep going on. There's no repeating pattern here. And this length, it'll be the same length here, same length here, same length here. So you can take square roots of numbers like 3. What you get is what's called an irrational number. So what we typically do is you could get the square root of 4, put that into your calculator, and you'll get 2. But the square root of 3, you put that into your calculator, you'll get, well, again, this long number, 1.73205, and I'll just say it goes on forever. So what we're going to do in this section is round off. And we usually round off to the hundredths place, or here. We usually round off to that digit. So to do that, we look at the number behind it. If this number is 5 or greater, we bump this up by 1 and then get rid of all the previous digits. But if this number is less than 5, we keep this number the same and then get rid of all these digits. So this comes out to approximately 1.73. So again, some numbers you can take the square root and things are great. So we could take the square root of, say, 9. Square root of 9 comes out to be 3. Then we go up to the square root of then. That turns out to be, it's going to be kind of complicated. Square root 10. Let's see. .16 228, and it goes on and on and on. We get this irrational number. Now, irrational means really a number that we can't represent as a fraction. You'll get numbers that have infinitely many digits behind them, like say 1/3. 1 divided by 3 is 0.33333 forever and ever. But this forever and ever of threes we can represent as, well, 1 divided by 3, or 1/3. And this is a fraction. But there's no fraction we can use to represent that number. So that's why we call it a non-ratio number or an irrational number. So again, we'll round off to the hundredths place, and that's the hundredths place. This number is less than 5, so this number won't change, and we get rid of the rest. And that's it. So sometimes that is something you can do. Another thing is sometimes people don't want you to round off. Sometimes they want an exact answer. And that's something you want to be careful of. Usually exact, I usually think of exact meaning rounding off, but really another way of calling this a symbolic answer. And that means if you take the square root of a number and you get an irrational result, don't do anything with, don't try to round it off. So for example, square root of 1 is 1. 1 times 1 gives you 1, so the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. But the square root of 10, as we saw, it's this 3.162, and it goes on and on and on. So when this happens, what we'll typically do is just call this, if they want an exact answer or a symbolic answer, we'll just write it as the square root of 10. So if your square root comes out irrational, what you'll find in algebra is they'll just say leave it as square root of 10, and that's it. But in our text, what we're going to do is this. We're going to round this off, and we'll call this approximately 3.16. That's what we'll do in our class. So that's it really there for working with square roots where they don't give you a rational answer, they give you an irrational number. For us, we're going to round them off, usually to the hundredths place or the tenths place. And then in some algebra classes, they'll say, you know what, if it turns out irrational, just leave it. We'll deal with it later. So that's it. Any questions? Let me know.